Imagine the ultimate engineering isolation, a massive floating factory operating continuously, day and night, in a deeply hostile ocean environment. Designing and operating a facility like this requires an engineer to master thousands of highly specific, intersecting technical parameters. All of this using spatial anchoring, specifically Tony Buzan's method of loci. This cognitive technique works by taking abstract, easily forgotten data and tying it directly to distinct, highly familiar physical locations. For this document, the vessel itself will serve as our ready-made memory palace to house the data. We will logically map the 12 technical sections of the specification document to 5 specific physical zones on the ship. Replacing flat text with a 3-dimensional mental map converts abstract parameters into geographical locations you can intuitively navigate. Let's establish our first spatial zone. Bring your mental focus directly below the surface of the water, looking up at the hull. Here in the water column, we anchor Section 1.0, the project overview, and Section 2.0, the metocean data. This chart maps forces on the hull. At exactly 104 meters deep, 100-year extreme currents hit 0.60 meters per second, creating massive drag. Chemically, submerged materials must also withstand 19,700 milligrams per liter of highly corrosive chlorides. Rising from the seabed through this water column are the flow lines and risers. We map Section 3.0, the development basis, to these physical pipes pushing hydrocarbons up to the surface. The ocean foundation acts as the ultimate dictating constraint. Because the environment is this hostile, every subsequent system we look at must be designed for survival first. Now shift the mental map upward, flying directly into the cavernous, double-plated steel of the main hull. This is Locus 2, where we store Section 7.0, the FPSO vessel itself. This specific hull was converted from a single-hull tanker and possesses a deadweight of over 261,000 metric tons to provide immense cargo capacity. A structure holding that much volatile fluid requires a rigid governing philosophy, known as the risk management hierarchy. We map Section 5.0, Health, Safety, and Environment, directly to this hierarchy. The document outlines 5 layers of defense for the crew: eliminate the hazard, prevent it, detect it, control consequences, and respond. Enclosing these shields is Section 4.0, Regulatory Requirements, the overarching legal framework enforcing these protections. This steel boundary functions as an actively regulated survival capsule, where every bulkhead and tank is governed by specific project codes. Ascend rapidly through the main deck and step forward into an incredibly dense, exposed labyrinth of process pipes and heavy machinery. We map the entirety of Section 6.0, the facilities, to this chaotic topside zone. This is where the primary stabilization systems operate. You have a 4-stage crude separation train to process the oil and TEG gas dehydration units. TEG, triethylene glycol, is a liquid desiccant used to absorb water directly out of the natural gas stream. Supporting those primary trains are critical secondary utilities, including seawater sulfate removal systems for reservoir injection and fuel gas conditioning units. The physical scale here is intimidating. These processing modules sit on the deck like multi-story industrial apartment blocks. To maintain this maze of steel, heavy overhead cranes are required. We map Section 12.0, Material Handling, to those lifting mechanisms. The factory deck is where the actual chemical alchemy occurs. It takes a violently pressurized wellstream fluid and forces it into stable, exportable commodities. Move your mental map to the extreme forward bow of the ship, focusing on the massive cylindrical column penetrating straight down through the hull. This specific location houses Section 8.0, the turret mooring system. The turret solves a severe mechanical problem. The ship must constantly weather vane or spin passively with the wind and ocean currents, but the riser pipes connected to the seabed below are entirely fixed in place. This diagram illustrates the critical mechanical solution, the swivel stack assembly. This complex stack allows lethal high-pressure fluids and delicate optical signals to flow upward through the static center and cleanly bridge the gap out into the rotating hull. This rotating joint prevents the constant movement of the 260,000-ton hull from twisting and snapping the rigid pipes connected to the seabed. Finally, fly away from the exposed machinery and pass through the heavy blast walls of the accommodations block. Enter the sterile, quiet environment of the central control room. We map Section 9.0, Instrumentation and Controls, strictly to the operator workstations here. This diagram shows the vessel's separated logic. The basic process control system runs daily operations on the left. The safety instrumented system holds override authority on the right. Errors in daily operations hit a hard digital firewall, ensuring they cannot disable the safety system. We anchor the final sections here as well. Section 11.0, Electrical, is mapped to the E-house switchgear feeding these consoles, and Section 10.0, Telecommunications, belongs to the satellite domes routing these signals off the ship. The control room serves as the digital brain, constantly balancing the massive competing physical forces of the ocean below and the factory deck outside. Pull your mental camera all the way back out to view the vessel floating as a single, coherent unit at sea. Let's test your spatial memory. If you need to find the rules for gas compression, where do you walk? You go to the factory deck. Where do you look to find the logic solver architecture? Step inside the central control room. And what physical zone must repel 19,700 milligrams per liter of chlorides? Drop down to the subsea boundary. Your brain now holds a complete map. All 12 sections of the engineering specification are permanently locking into their distinct locations on the vessel. The FPSO is a strict tri-part megasystem. The marine hull, the chemical topsides, and the turret interface all operate in absolute dependent unison. This architecture prioritizes inherent safety. The health, safety, and environment specifications dictate the materials, the logic, and the physical layout of every deck. Spatial memory transforms a list of engineering specifications into a functional mental blueprint. You now possess a geographical map of a multi-billion-dollar deep-water survival machine.